Rahul, can you hear me?
Not sure about Raul, but I can.
Oh, okay, thank you. Thanks.
Sorry if I interrupt you, but seems we are not hearing anything. I see the slides is switching, but no any sound at all.
Yeah, me too.
Hello, hello. Do you hear me? There is no sound on the online translation.
I can, but I don't know about them. So have you seen the presentation?
I see the slides, but there is no sound,
Yeah.
and as far as I understand, no one is
Yeah.
able to hear something.
Yeah. Everyone is complaining on YouTube, and it's too bad. Oh, okay, they can hear us, but they can't hear the people in presenting the slides.
Yep, funny. And I have no idea how to stop them.
With the first project from Rachel. She is working at the refresh of the Uyuni website, and in particular, she is also focusing on the accessibility of the website. Rachel was already a mentee the previous edition of the Google Summer of Code, and in that case, she was working on the accessibility aspect of the web UI of Uyuni. Now let me switch to Rachel. Can you bring her on stage?
Rachel's already up on stage. You want her screen?
Yeah.
She has to share.
Just a moment.
I don't see it as an option, but she hasn't shared yet.
Rachel, can you hear us?
I believe that's her screen. Stage.
Yeah, I can hear you. Can you hear me?
Okay. Can you try to share your screen?
Yes. Can you see my screen?
She's on stream. You can see it.
Can I go on stream? Yeah.
Yeah.
Okay, we can see your screen.
Oh, okay. Hello, everyone. My name is Rachel Editayo. and I'm a Google Summer of Code intern working on refreshing Uyuni websites and improving its accessibility and responsiveness. And my mentors are Marina and Raul. So in this presentation, I'm going to talk about web accessibility and the progress we've made so far with Uyuni website. So to begin, what is web accessibility? Web accessibility involves designing websites, softwares, or any digital products in a way that includes everyone, regardless of their abilities or disabilities. So, accessibility is about overcoming digital barriers and ensuring that no one is left behind from using your website or your digital product. The four foundational principles of accessibility, according to the Web Content Accessibility Guideline, includes making your website or design perceivable, operable, understandable, and robust. And by perceivable, we mean making the content visible and audible. And you can do this by adding alternative text to your images, using high contrast colors between the text and its background, and making sure the font size you're using are appropriate. And by operable, we mean making the content interactive and usable. And you can do this by integrating keyboard navigation feature.
Okay, it looks like we lost Rachel. Hopefully she can rejoin.
Let's give her a moment. Shall we switch to?
Okay, it looks like the demo effect. We might be having some connectivity issues with Rachel. We will try to go next to Harun, and if she recovers the connection, we go back to her. So Harun, are you available? Can you hear us?
Yes, I can hear you.
Okay, so you can try to share your screen.
Okay. Okay, hopefully you can see my screen now.
Yes.
Yep, now yes.
And we can
Okay.
hear you, so you can get started.
Okay, thank you, Raul. Thank you, Marina. Hello, everyone. Hope you're having a good summer. My name is Harun Hussein. I'm an engineering student from Tunisia and currently working as a Google Summer of Code mentee with the OpenSUSE organization under the Uni project. And today we'll be trying to present the lazy RepoSync service, which can be seen as an upgrade of the current RepoSync service used by the Uni. So let's start with a quick overview about the current RepoSync, also known as the Spacework RepoSync in the command line of the Uni server. It's actually a tool that synchronizes software repositories into Uni channels, which means that when we create a channel and associate it with a repository or maybe multiple repositories, the RepoSync takes care of synchronizing all the packages from the remote repository into the Uni channel. And the current RepoSync actually downloads all the packages of a given repository and synchronize them and deliver them to the client. Here's a quick overview of the workflow of the RepoSync. So if for any of you who have used the Uyuni web UI, you might be familiar with this section about synchronizing repositories. So after creating a channel and a repository, the end user might want to synchronize those repositories. And with that, a sync request is sent to the Uyuni server, and the Uyuni server tries to connect to the remote repository and download all the packages all the packages, process them, and save the metadata into the database, and then save the actual binaries and files into the file system. So what's the problem with the current RepoSync? The problem is that, as we've just said, the RepoSync downloads all the packages of a given repository, which means that even if the user might not use all the packages or even most of the packages, the RepoSync still downloads all the packages and store them locally. And some repositories have thousands of packages in their repositories. So downloading this huge number of packages and store them locally, and we might not use actually most of these packages will not be very efficient, because this will very much affect the bandwidth when downloading the packages, processing time, because we might be processing thousands of packages or maybe hundreds of packages that may not be used by the client. Also, for the disk space issue, we might be storing a lot of packages that we might not, the end user might not be using, or maybe even if he use these packages after 1 year or so, it's still gonna be a waste of time during the whole year, because the disk space is occupied with some packages that are not used. And of course, memory issues, because even if you're using parallel processing streams, there's gonna be always memory issues dealing with this big number of packages. So this is where the new lazy RepoSync idea comes from. And the main objective is to separate the workflow into two separate workflows. The first workflow is to download the packages metadata only at the first step, and then download the packages using the cached metadata at a second step. And the download can be either on demand, which means that the packages might be downloaded when they're needed, or on opportunity. And this can mean a lot of things, but basically it's gonna mean that the server will try to download some packages based on some rules when the server is downtime or based on some schedule. And here's the new workflow. It's actually the same workflow, except that same workflow as the RepoSync, the old one, the current one, except that we separated the download process into two workflows. Download the metadata as a first step separately. So we're gonna download only the metadata of the packages, process them, store them locally. And then as a second step, we can download the actual packages and the binary files of these packages. And we should note here that the client might not be necessarily aware of what's happening in the background, which means that after synchronizing the metadata, for him, everything is ready to use, and all the packages listed on the Uyuni UI or on the CLI can be used. And if a package is not there, the Uyuni server will take care of that and download the package immediately and deliver it. So the key features of the new lazy RepoSync is that, as we've said, the whole repository metadata is synced. All packages metadata is synced and delivered to the client. And the packages are downloaded either immediately if the packages are frequent, because some of the packages are of high priority in a given distribution, and we assume that the end user will be very likely to use those packages after a very short period of time of the synchronization. And another way of downloading the packages will be based on the client's request, like we've just said, which means that when a client wants to use a package in a given repository and it's not existing on the file system, the Uyuni server will try to connect immediately to the repository, download it, parse it, and deliver it to the client. And the last strategy will be defined based on a defined schedule, actually. So we can sort the packages based on the size, based on the frequency of use of these packages, and define some rules that can run automatically by the Uyuni server to download the packages. So what we've done so far in this project, we almost completed the synchronization of the RPM's packages repositories. And this includes downloading the two main important primary metadata files, which are the primary XML and file lists, using streams to avoid downloading the whole thing at once. This might be efficient in terms of memory and processing. Process these files using SAX parsers and pull them, which are two different libraries or APIs that provides us with the ability to parse XML files incrementally and not loading the whole thing into memory, because some of the files may be very big in size and loading them into memory completely might not be very efficient. And of course, after processing, we imported the packages into the database, and we've used some of Spacewalk's current import lib functions to do this. There are very powerful functions provided by the import lib that allows us to efficiently import the package's metadata into the file system. And the next step will be completing this, the same job for Debian packages, and jump over to the download, which is the second part of the project. And yeah, that's it. Thank you very much. And if you have any questions, you can reach out for us or Alex, Cedric, or anyone in the community. They will be very happy to answer. Thank you.
Okay, thanks a lot, Harun.
Okay.
I don't really know whether we can
Yep.
take questions here.
Okay. So I think I should
Um,
exit. No. Yeah.
Okay, so I would say we have Rachel back, and she had problems with the connections. It's not only us here in live with the demo effect. So maybe Rachel, if you hear us, maybe you can pick up from where you left.
Okay, sorry for the interruption.
No
Let me try to
worries,
share
no
my screen.
worries.
okay.
It was even worse here, so don't worry at all.
Feel free to share the screen, don't worry.
Oh, thank you. Can you see my screen now?
Not yet.
Not yet?
What about now?
Not yet either.
Wait. Give me a second, it's on me. Try again, and I need to put your screen on stage. Give me a second. Share again.
Okay.
Okay, just a moment.
Okay, it's loading and we can see it again.
Okay. So I was talking about the 4 foundational principles of web accessibility, and that includes making your websites or your designs perceivable, operable, understandable, and robust. And by perceivable, we mean making the content visible and audible. And you can do this by adding alternative text to your images, using high color contrast between your text and the background, and making sure the font size you're using are appropriate. By operable, we mean making the content interactive and usable. So you can do this by adding keyboard navigation feature, making your website responsive on different screen sizes as well. And by understandable, we mean making sure the information on your website uses a simple and understandable language, or making it easy for your users to translate from one language to other languages. And also using visual aids or illustrations on your website for better understanding. And the last principle, robust, means making sure your content is accessible across different technologies. For example, making it compatible with assistive technologies like screen readers, and also using appropriate HTML and ARIA attributes where needed. Also, using clear and consistent ID and classes in your HTML code. So what are the benefits of web accessibility? First, it improves the user experience for everybody, not just for those with disabilities. Second, it improves your brand's reputation because it shows your users that your brand cares about inclusivity and diversity, and that would have a positive impact on your brand image. The third one is legal compliance. Many countries have laws that makes it compulsory for websites to comply with web accessibility standards, and failure to do so can attract lawsuits. So making your website accessible for everyone can save your website from attracting lawsuits. So how do we test our sites for accessibility errors? We use this tool, the Wave tool. Can you still see my screen, please?
Yes.
Yep.
Oh, okay. So we use the Wave evaluation tool to test for accessibility errors on our website. And you can get this tool from your browser's web store. So once you've installed it, you can start using the tool by clicking on the icon in your browser's toolbar. So I'm going to use the Uni web page as an example here. And I've started the Wave tool. As you can see, the Wave tool will analyze the HTML, the CSS, and JavaScript code of your web page to identify potential accessibility issues. So this tool uses a set of evaluation criteria based on web content accessibility guidelines to assess the page, and it groups the identified errors into categories. For example, the errors category. This category refers to some critical issues that must be fixed on the page. But for this particular page, we fixed the critical issues identified by Wave. So the next category is the contrast errors, and it refers to color contrast issues that may affect the readability of the page's content. The third category is the alert category, and this refers to issues that may or may not be accessibility errors. So in cases like this, we manually check to see if they are really accessibility errors. The fourth category is the features category, and it refers to accessibility features that have been implemented correctly. The fifth category is the structural elements category, which refers to errors with the HTML structure of the page. And the last category is the area category. So this category points out some HTML elements that needs to be improved by using some area labels and some area attributes. So in conclusion, we've addressed some accessibility issues in the website, and we'll continue to identify and fix more issues in the coming days and weeks. So I hope this presentation has encouraged everyone to continue to consider and prioritize including web accessibility in their work. Thank you for your time.
Okay. Thanks a lot, Rachel.
Thanks for the demo, and let me add that now the Wave tool was reporting 0 errors because, of course, Rachel already fixed some of those issues. But at the beginning of Google Summer of Code project, let's say that the accessibility of the Uyuni website was not exactly good. So thanks a lot, Rachel, for the work that you already did.
Okay, so we can go next to the next presentation. It's going to be from our colleague Victor about the improvements for Sol. And Victor, maybe you can try to share your screen.
Yep,
Can you hear us?
I hope you hear
Yeah,
me well.
we can hear you.
Yeah.
And okay, we have to let you.
1 second.
Yeah, it takes some time on our side, so don't panic.
Okay, we are just adding you to the stage. Just a second.
I'm chatting a bit. I just opened the online stream from the YouTube on the mobile phone and put it next to me just
Okay,
to be.
we can see your screen now, so you can go ahead.
Yep, great. So I'm Viktor Zhskov. I'm working in SUSE, and today I'm going to present you some of the upcoming fixes for the Salt, particular mostly for the master side of Salt, but some of the fixes will go to the Minion as well. But this fix is mostly affecting the performance of the master, as they are preventing some of the not really useful calls from the minion side, and provide some headroom for the master to solve some useful events instead of the solving these issues. So just to give you some background of the possible issues of the large scale environments, and probably I need to describe the large scale at this moment, just because it could be not really clear what we are defining as the large scale. And to be fair, there is no exact number, and it mostly depends on the use case of the particular environment and the exact content of the environment. It depends on the number of the minions for sure, and the number of the proxies used in the environment. And one of the main issues which can face the large scale customers, the fact that in case of losing the connection between the Uyuni server and Uyuni proxy, the Uyuni proxy is able to collect a lot of the zero MQ messages, in this case on very low level of the zero MQ transport. And in case of restoring the connection to Uyuni server, all of these messages inside the buffers of the internal buffers of the sockets, zero MQ sockets, will be pushed to the master almost immediately. And even if you have in your environment at least two proxies, they could collect thousands, and in some cases tens or even hundreds thousands of the messages. And in most cases, these messages are almost identical, as most of the minions are trying to re-authenticate, as they are not getting the response from the master. So they are continue trying to re-authenticate. So in this case, on the Uyuni proxy side, there is a lot of the messages collected, and then, as I mentioned, they will be pushed to the server. And in this case, it's quite dangerous for the master, as it will not be able to serve for such amount of the messages in appropriate time. And it just shows us what I described, with the pushing of these messages to the server. So, and to avoid this issue, we already pushed the improvement for the salt broker. Is the service is used on the proxy side to solve the salt traffic between the minions and the master itself. Actually, this particular service is quite simple one, and it just connect two pairs of the sockets to each other and just forwards these messages, and not really passing them or reading. And there was no any kind of logic to detect the connection loss from the master side. And first of all, there are a list of the parameters related to keep alive options for the socket, which could improve the detecting of the connection loss. And the other important one is the wait for backend parameter, which actually acts as a kind of interrupter for the for the connecting for the collecting the messages. In case of setting this wait for background to true, the backend socket, which is connected to the master in this, or not the backend socket in this case is the one which is connected to the master, but the front-end socket for the minions will be opened only in case if the backend connection to the master is available. So in this case, it prevents minions to send the messages to the broker itself, to prevent them collecting on the broker side. and the rest parameters are drop after retries, and the connect interval, they are quite flexible, and you can find this description of these parameters in the default config file and also in the PR specified on the bottom of the screen. I would personally recommend the parameters set on the right side of this screen, just because it makes the broker acts as the master and be more aggressive in case of dropping the connection to the master. Oh. I saw some blinks on the screen, so I hope you should see it well right now. So the next parameters are for the minion side. In the large-scale environments, it's quite challenging. Some use cases when the number of the minions should boot in the early morning, for example, if the kind of retail or any scenario which allows the devices to be turned off for a while, and if there are some chances that these minions will start almost immediately, it will cause the huge amount of the authentication attempts almost the same time. So to prevent this issue, we recommend to set extra parameters to randomize the delay before initial connection to the master and reconnection attempt to prevent this huge amount of the events sent simultaneously. So for the Salt Master, we also provided some fixes. There was a huge investigation with one particular customer, and at least I think 2 more were affected with the same issue. The symptoms are quite simple. On the master side, you could notice that there is a huge workload on the CPU and memory, and one of the processes, in this case, it's shown as the title event publisher, but in most cases you will see just the salt master process with no any extra title. But the one which is eating the most memory, usually the exactly event publisher. And we started investigating the root cause of this issue, and as the final result of this huge memory consumption is the usually out of memory for this particular event publisher process. And the bad thing of this occurrence actually that in case if the event publisher will be killed with the OOM process, the salt master service will look like running, and systemd will not detect that the service is failing, but actually the salt master will not process any incoming events from the minions or even from the web UI, etc. So it just do nothing and just wasting the resources of the system, and you will not be able to use it. So from the log point of view, you can notice something like these tracebacks, and it could be a huge amount of different tracebacks depending on the exact moment when the connection was with the event publisher was interrupted. But in any case, there will be a lot of the tracebacks, so it's quite easy to notice in the logs. And our goal was to prevent the situation which could be possible in the highway with the engine when it tries to burn. And instead of getting this situation on the highway, we tried to reproduce it in the isolated way in the special prepared environment. And as the result of it, we found that there are some internal issues possible, particularly mostly depending on the amount of the workers specified for the master in the config, and the most important one in this case is the number of the subscribers of the event which are reading the data from the event publisher. It could be MJ events engine, reactors engine, just a simple command salt run state event which can be run with the CLI, and you can watch the event publisher events on the screen. So it's also the subscriber for the event publisher. And the problem with the event publishers that in case if the event publisher is causing the delays on reading the events from the event bus, the event publisher itself has to hold these events until they will be read by all the subscribers, and it could cause huge growth of the memory consumption of the event publisher in this case. And despite of the direct subscribers, they could be also the batch async processes run inside each of the worker, and each of the batch async process. Not the process. It's not the disync process, but the process spread in time with the async subsystem of each of the workers. And for this particular customer, there was the case when, in some cases, there were about more than 1,000 and half batch async process run simultaneously. So each of them were trying to create the subscriber and trying to read these events, and it was causing this huge growth of the memory consumption of the event publisher. So what was the improvements we already pushed to the next updates? First of all, the huge refactoring of the batch async system to avoid creating the single subscriber for each of the batch async call, and instead each of the workers is creating just a single every publisher stream to read the events. And we also make the salt master to be able to self-recover after such issues, and in this case it become more durable and self-recovering, as I said. And there are some minor general improvements with the removals of the not used code, not used reading the data, imports, etc. For example, one of the dropped unused import is significantly increasing the startup time of the saltmaster process, about 2 seconds in some cases. And the login subsystem also became more lighter and way less blocking than before. So our recommendations for some parameters for the saltmaster, as I mentioned, mostly it makes sense for the large-scale customers, but it depends on the amount. In some cases, you could see such issues even if you reaching, for example, 100 minions, you could be already affected with some of these issues. And the number of the proxies in this case could just amplify these issues. So first two parameters which I could recommend to set is the auth events set to false and minion data cache events set to false as well. So these two actually prevents the saltmaster to expose in the event publisher the events which are not really used by Uyuni. And I personally don't know any benefits of having these events exposed in the event bus, and not sure if there are any examples which could of the customers who need them. So the next one is the connection cache. Connection cache actually suggested in the upstream salt to be used with the huge amount of minions, but seems that this feature is kind of broken for a long time in the upstream salt. So and even if we try to fix it, it will not get any proper benefit on this connection caching mechanism, as in my tests I didn't find any case when it improves the speed of the master. So I would suggest to not to enable it and keep the default false set. With the latest batch async implementation improvements, we introduced the list of the extra batch async parameters. The main one for them is the batch async threshold. This value is setting the threshold for triggering the batch async process in general. So in case if the amount of the targeted minions less than specified amount of the threshold, ordinary async call will be fired instead of the batch async, and batch async will be fired only if the if the amount of the targets exceeding this threshold. And in case of setting -1 as the value, it will use the batch size parameter set with the call for the particular single call of the batch async. So the other possible improvements which we can get is the data collected with the master starts. If you enable it to true and set the interval of exposing these extra events with the salt event bus, you will get the extra statistics for each of the worker, how much time it solves the internal calls and how much calls was solved. On base of these values, you can slightly tweak the number of the worker threads to reach the better performance. I will tell a bit later some of the tricky points about it. So the other recommendations is to use the reactor, especially on the frequent events, as the reactor engine itself is quite heavy and it has to spin up a lot of different things internally or on each of these events. And as this spin up is including the laser loader and there are some heavy calls, it could cause a lot of delays on serving some of the requests, and such customers could be in danger on these particular tweaks. So one more key point, that in case of implementing any kind of customization with the external salt models, reactors, etc., you should be aware of the exception handling. In case of avoiding the exception handling, this exception could be handled by the master, but not all of them, and in some cases it could cause the problems on the salt master side, and in the most dangerous cases it could lead to denial of service of the salt master itself. And with this particular customer, we found also the issue with the pillar rendering, and the issue was the fact that they were using the grain matcher on the top level of the pillar top SLS file. So they have a list of the identical rules with just a different values of the minion ID, and then they have same amount of the files invoked by this top SLS file, and it was causing huge delays on rendering the pillar data. So the suggested fix was implemented, and according to the tests, we dropped the time, the average duration of pillar rendering from 4 seconds to 0.8 seconds. It's not yet really perfect, but we are trying to check one more possible solution there, but not yet.
Victor, we're running out of time and people are
Yep.
ready.
Actually, I
Just
was
on time.
just finished. Yeah, I can show some extra metrics on the monitoring system if you want, but if we are out of time, it's
I'm
okay.
afraid we won't be able.
Yeah.
Thanks a lot for the presentation, Victor. Is there any question in the audience for this or for any other presentation, or maybe from the chat?
I think there could be questions from the users who have some large-scale environments, but if you have really tricky questions, you can reach me with the email, I think.
Okay.
It will also be
I
useful
will
for
also
us.
try to give a reminder in the next community hours, or maybe somebody comes up with anything, either for your presentation or from the Google Summer of Code ones. Okay, with that, we are done. Thanks a lot for attending, and see you in the next edition of the Uyuni Community Hours, as usual, the last Friday of the month. Thank you.
Thanks
Goodbye.
for joining. Bye.
Bye.